Hello. In this video, we are going to discuss about a new project called Fire Alarm System using temperature and gas sensor. And I'm using a simulation software called Tinkercad. And in order to create a circuit for our project, we need to click on Circuits and select Create New Circuit option. Upon doing so, a blank workspace will be open and a components list will be available. And we have to search for Arduino board in our components list and drag it onto the blank workspace. Here it is there on the workspace. Now we should search for a breadboard so that we can mount the required components on it, and I'm dragging it onto the workspace. It is better to arrange the components a little so there would be space for a lot other components. Now I'm searching for a temperature sensor and dragging it onto the breadboard. Similarly, we also need a gas sensor and it is dragged onto the breadboard. Now for alerting purposes, we need an LED and a piezo buzzer. So I'm going to search for piezo and it is dragged onto the workspace. Now we need an LED and LED is here. So these are the main components. The basic principle of working of the temperature sensors is the voltage across the terminals. If the temperature rises, the voltage also increases. So for every 1 degree change in temperature while the sensor is performing, then there would be a voltage change of like 10 millivolts. So this is how the temperature sensor works. A gas sensor is a device which detects the presence or concentration of gases in the atmosphere. Based on the concentration of the gas, the sensor produces a corresponding potential difference by changing the resistance of the material inside the sensor, which can be measured as output voltage. This gas sensor can also be used to detect smoke. The gas sensor detects the concentration of gas in parts per million and outputs an analog value that can be converted to digital measure using inbuilt analog to digital converter of Arduino. Coming to the circuit connections of the components, first this is the temperature sensor. Before giving the power signal to it, we need to set the basic pins, that is 5 voltage, which is the power, and let's change the color to red to indicate that it's the power wire. Similarly, we need a ground and let the color of the wire remain green, which indicates that it is the ground wire. And now coming to the connections of temperature sensor, the power should be given to a 5 voltage and the wire is changed to red. Similarly, ground should be given to the ground pin. Let the color remain green. Now the Vout signal should be given to one of the analog pins of Arduino, let's say A0, and the connection is given. Let's change the color to some different color to indicate that it is an input wire. Similarly, out of 6 pins of the gas sensor, 3 of the pins should be connected to the power, and as you can see, I'm connecting 3 of the pins to power, and let the wire be red in color. And again, the gas sensor input should be given to one of the analog pins, let's say pin A1, and I'm changing the color, which is similar to the temperature signal color, that is to indicate that it is an input signal. And again, I'm giving one of the connections to ground, and we also need resistors so that the amount of current passing through the sensors can be restricted. This is due to the fact that when excessive current passes through the sensors, they might get damaged and burned out. So a resistor is necessary. And coming to the connections of piezo, the positive pin should be given to one of the digital pins, let's say pin number 7. And we can also change the color to indicate that it is output signal. and negative pin is given to the ground. Here I am changing the color of the wire, and again LED for indicating the output itself. Cathode terminal should be connected to the ground, and as I mentioned before, resistor is necessary so that the sensor or an LED won't be burned out because of the excessive current flowing through it. And let's change the color to something else which indicates the output signal, and we can also change the LED colors. As you can see here, I remade the connections to make the circuit look more presentable. Here the blue wires indicate the input signal and orange wires indicate the output signal. The gas sensor is connected to A0 and temperature to A1. Similarly, piezo is connected to 7 and LED is connected to pin number 13. Let's program our Arduino with the code, and to provide the code we need to click on code option and go to text so that we can type out the code. Click on continue. We can just remove the default code provided by the simulation software and replace it with our own code. As you can see, it's here. We are taking the temperature, so that's why float temp is given. And as I mentioned before, Vout is the output of the temperature sensor, and Vout1 is when the temperature increases and a new voltage will be produced. And LED is given to pin number 13, which is mentioned here. Gas sensor also outputs some value, which might be the concentration of the smoke or some gas in the surroundings. And piezo is connected to pin number 7, which is given here. Coming to the Arduino setup, pin mode A0, that is the gas sensor, is considered as input, and A1 is considered as input as well, which is nothing but the temperature. That is, the output of both gas sensor and temperature sensor is considered as the input to Arduino. And now LED and piezo, which are used for alerting purposes, are set as output. That is, when either temperature is high or the concentration of smoke is high, LED or piezo will be set to high. And serial.begin is given, which is to activate the serial monitor. Coming to the loop, as I mentioned before, Vout is nothing but the output of the temperature sensor, so it can be inputted by using a command called analog read of A1 because temperature sensor is connected to pin A1. The new voltage is calculated by using this logic. Similarly, gas sensor is analog read A0. Now, for alerting purposes, if the temperature is greater than or equal to 80, this is the threshold value, 80 is the threshold value. So if it's more than 80, then the LED is set to high, else LED is set to low. Again, if gas sensor is greater than or equal to 100, where 100 is the threshold value of that sensor, then piezo is set to high, or else piezo is set to low. Now, to differentiate between the gas value and the temperature value, we are using serial print, where it clearly types out which is what value. So in degrees is equal to serial print types the temperature, and in gas sensor is equal to serial print, it types out the gas sensor values, and a delay of 1000 milliseconds, that is 1 second, is given. To observe the output of the code, let's start the simulation. But before that, we need to click on serial monitor so that we can observe the changes. So I'm starting the simulation. As you can see, the initial values are 24 and 85. Let's click on here. As you can see, the smoke is concentrated around the gas sensor. That's why the piezo is set. The piezo is buzzing. Now let's move the smoke away from the gas sensor. As you have noticed, the value dropped to 85, which is less than 100, the threshold value we gave. So that's why piezo stopped buzzing. Again, let's bring the concentration, let's bring the smoke closer to the gas sensor. Now the concentration of the smoke increased, so that's why piezo started glowing. Similarly, let's observe the temperature sensor output. So I increased the temperature. As you can see, the LED started glowing, and also the temperature is 124, whereas the threshold value is 80. Let's drop the value a little. Now the new temperature is 67, which is less than 80, so that's why LED stopped glowing. Let's increase this again. Now the temperature is 105 and LED started glowing. So this is how the code works, and fire alarm system is set. So thank you for watching this video.